We need to go through a couple of important mass-related definitions because there are multiple versions of what I would call density in this class that come up, and they have different symbols. So let's just go through this quickly. So mass density you will definitely have seen before in thermodynamics, right? So that's usually given the symbol rho, the Greek symbol rho, and defined as mass divided by the volume of whatever fluid that would be. So note that in fluid mechanics, the letter V actually comes up in a lot of different contexts, right? So like velocity is all over the place in particular. And so it's common to use the symbol V with a horizontal line through it to mean volume. That means volume. So mass M divided by V with a bar through it is the mass density. And of course it has the units kilograms per meter cubed in SI units. There's a related definition of, it's sort of like density, but it's more related to how much stuff weighs. So there's a type of density called the specific weight. It's given the symbol gamma, and it's really just the density times whatever the gravitational constant is. So it's kind of like the number of newtons per meter cubed rather than the number of kilograms per meter cubed. So this has more to do with the forces that are created by a fluid rather than just like the amount of fluid that exists. So the definition is just the total weight divided by the total volume, or equivalently the mass density times the gravitational constant. So that's given. So that's specific weight, and that's given the symbol gamma. Another related one that is often used, especially in the context of buoyancy, is something called specific gravity. So specific gravity sounds a lot like specific weight, but it actually, for whatever historical reason, is not defined the same. So specific gravity actually means the density of a fluid divided by the mass density of a reference fluid, which is almost always water at atmospheric pressure and like room temperature. Specific gravity basically is a way of talking about whether something is heavier or lighter than water. So like oils typically have a specific gravity that is less than water. So like a specific gravity of 0.7 would not be an uncommon number for like crude oil or something. So anyway, specific gravity is defined as mass density divided by the mass density of a reference fluid, which is almost always water. And of course, because of the way that it's defined relative to like one thing relative to another thing with the same units, the units of specific gravity are dimensionless, so they're just a number. And that's really all you need to know. So those three definitions come up usually in three different contexts. And I'll be honest, so specific weight is actually, so that gamma character is used throughout this book. And I've seen it used in some other places, but it is actually more of an old school thing to do. I think nowadays most people actually just write out rho times g rather than use the symbol gamma for specific weight. But you'll see it, and so you should be aware of what that is when you see it.